Hey CW Apes, Mr. Kennedy here. This is part one of your chapter 15 notes on energy efficiency and renewable energy resources. Today we're going to dig into all kinds of, renewable energy options that are out there. We're going to talk about green buildings. We're going to talk about solar energy. We're going to talk about wind and biomass, hydroelectric power, even geothermal. To kick things off, we're going to look at something called your utilization efficiency. Like, how efficient are you at using the energy that is out there? Take, for example, compact fluorescent light bulbs. Do you have them in your home as opposed to incandescent? A compact fluorescent light bulb produces 4 times as much light for the same wattage and lasts 10 times as long as a regular incandescent light bulb. LED light bulbs are even more efficient and they consume 90% less energy. What's in your lamp? Okay. One of the easiest ways to save energy around the house is to just turn off and unplug appliances. You know, most of the time we turn things off and think, well, off is off, but appliances on standby can actually represent up to 25% of a typical monthly electric bill. Putting a computer to sleep can actually save 90% of the energy that that computer would normally require on a month by month basis. So at the end of the day, this need for renewable energy resources is really centered around just how efficient we as a people can be with the energy that is out there. Our population continues to increase, and as it continues to increase, everybody wants what everybody else has. And who are we to say that they can't have it? Like, lights that come on at night. We're not asking for much, okay? So that being said, for each new home, that's more power, more pressure on the power grid. We all have to do our part. When you think about standby consumption alone, that's just walking around your house when the lights are out, but things are on standby. Look at what we've got here. 44% of your energy, standby energy, comes from home office devices. Like, I know in my house, I've got, computers, I've got televisions that when they're off, you still have the little red light there. You've got all these little things like that. You might have a scanner, you might have a printer. Who knows what it is, but every time there's a little red light on, there's power being pulled by that device. So maybe when we're not using it, we should just unplug the thing altogether to save standby energy. That provides a little bit more energy for the grid for somebody else. Other things to think about in terms of your efficiency, like, what's your thermostat set at? Is your house, like, air conditioner set at like 77, or maybe is it 80? There's all kinds of little things like that that you can do to improve your energy efficiency. Let's talk about green buildings, since I brought up the idea of air conditioners. A green building is a building that, has extra insulation and maybe coated windows. It has things like solar panels on its top to help cut energy costs. The more efficient we can become with our use of energy, then the less energy we're going to have to produce. By adding insulation to our house, it can stay warmer in the winter, cooler in the summer. By taking advantage of like passive solar heating, just facing our house the right direction, or adding or removing trees from around our property, we can also add to that quotient and reduce the need for heaters and air conditioners. In Sweden, just to give you an idea, super insulated houses are now being built in Sweden that use 90% less energy than conventional houses here in the United States. They've definitely figured out something. Transportation is another issue. So I keep telling people, if you won't buy it, then they won't build it. And we're actually seeing that in the transportation world. And what I mean by that is you look at cars that are on the road today and compare it to like the 70s and 80s. Back then, those cars were nothing but steel, had huge V8 engines, and probably got somewhere around 8 to 10 miles to the gallon. As gas prices kept going up and up, the public, I wanted to say American public, but really it's the global public, like, put their foot down and said, you know what, we are not going to buy these cars because it costs me like $150 to fill the gas tank, right? So the auto industry responded by building cars that are exponentially more efficient than the ones of the past. I actually saw a, Mythbusters thing the other day, and it was kind of interesting because they raced a car from the 70s with a big like V8 engine in it with a like Honda Civic. And everybody assumed this big 400 cubic inch like V8 engine from the 70s would just destroy the Honda Civic. Boy, were they wrong. The Honda Civic blew the doors off of that older car. So on top of efficiency, they're still getting performance, which seems to be what like the American public's love affair is when it comes to cars. They want performance, they want speed, they want comfort, whatever. But improving our energy efficiency in terms of transportation is also huge. Okay, getting more miles to the gallon and having cars that last longer. Automobiles and light trucks actually account for 40% of U.S. oil consumption and a fifth of its carbon dioxide emissions. Raising the average fuel efficiency in the U.S. by just 3 miles to the gallon would save consumers $25 billion a year and save more oil than the maximum expected production from drilling in the Arctic National Wildlife Refuge. In the 1970s, when oil prices rose, U.S. doubled auto efficiency and finally reached a standard of 25.9 miles per gallon in 1988. Unfortunately, by 2004, it went down to 20.7 because we entered an era where everybody wanted a big SUV. We're flipping the switch on that one, and now it's all about hybrids and electric vehicles. So that number is going to change again. To be more efficient, you could buy a hybrid gasoline electric car. For short trips, you could walk, you could ride your bike. There's all kinds of options, okay? Plug-in hybrids are even more efficient than standard gas cars alone. An electric car is even more efficient than just a hybrid. The reason, I say that is that the hybrid still has a gas engine that will draw fuel periodically. If you have a straight plug-in electric car, then that's not a problem, okay? You could buy a plug-in hybrid car which recharges batteries from a household electrical outlet at night. Electrical costs are equivalent to like 50 cents per gallon of gas. I mean, that's pretty awesome. Yeah, I know. You're going to argue that, well, my PG&E bill is going to go up. So put solar panels on your house and that'll cancel that out, right? We will need to generate more electricity, but we could capture pollutants easier at the plant than we can when you're driving all over town in your car. You could buy a diesel. Diesel kind of gets a bad name in states like California. There's more diesel fuel produced per barrel of oil than any other fuel type, but yet diesel fuel is like the most expensive stuff that you can buy at the gas station because California slaps all kinds of restrictions on it. Okay. There are vehicles called turbo diesels that actually get crazy awesome gas mileage. Honda currently sells a diesel in the US that gets 62.8 miles to the gallon. That's pretty amazing. Diesel plug-in hybrid could make the U.S. entirely independent from imported oil if we went that route. But like I said, diesel gets a bad name. Here's just a couple of hybrid options: the Toyota Prius, the Honda Insight, right? There's lots of others. I just grabbed these two as individual options, okay? This also kind of shows you who's using what in terms of, gas-operated cars versus plug-ins and hybrids, and who's got, like the bigger cars and the smaller cars in these two graphics. Okay, you can kind of see where the U.S. rates. To kind of give you an idea how the plug-in hybrids work. I put this graphic in here for you to kind of give you an idea that both of these things have electric motors. In a conventional hybrid, they'll have a gas engine with their electric motor. In a plug-in hybrid, it's just electric motors and batteries only. The one thing that is still kind of, a concern or something that I don't know that's really been looked at yet because we haven't had these on the road, I don't think, long enough yet, is what are we going to do with all the batteries for our plug-in hybrids when they need to be replaced in 5 years? Hopefully there's a crazy awesome battery recycling process that will play out and they don't end up in the landfill. Okay. Here's some other electric vehicles. So we've got the Chevy Volt. We've got some Tesla motor vehicles. These are zero emission vehicles, but there is a catch. And I do say there's a catch because you still need the electricity, and you're still going to be burning fossil fuels to actually produce things like rubber tires and stuff like that. But at the end of the day, right, still a much smaller footprint than just driving a gas car. Okay. All right. California law required the building of zero emission vehicles. So corporate priorities changed, and basically, we've started making vehicles that are much more efficient than ever before. The GM came up with this idea for an ultralight car, and the ultralight car got shelved because the California laws, for building zero emission vehicles, like, changed their priorities. Okay. EV1, same thing. Okay, EV1 has been around since 1996. You might every once in a while see one of these still on the road. California law changed again, and corporate priorities changed, and the EV1s were mostly recalled and crushed back in the 90s. The whole idea of consumers, if you ask for it, they'll buy it, like, has really started to kick in the past decade, and that's why the Toyota Prius and other, like, hybrid cars, electric cars, have become as popular as they've become. Okay. Hydrogen fuel cells. So, as an alternative fuel source, instead of looking at fossil fuels, we could power vehicles with hydrogen fuel cells. To kind of give you an idea of what a hydrogen fuel cell is, basically, it uses hydrogen gas as fuel. Probably the biggest, like, problem with hydrogen fuel cells is there's not, like, a huge distribution system for hydrogen gas like there is for gasoline. So you'd have a hard time, like, filling your tank. The plus is that when you burn that hydrogen fuel, their only waste product coming out the tailpipe is water vapor. Is super awesome. Since there's not a distribution system, it could take as many as 20 years before this actually comes to market. There have been some people that were really worried about the hydrogen fuel cell because they thought, well, if I get in a car accident, like, I'll blow up. But the risk of that is no greater than, like, blowing up in a regular car accident. Okay. Governments in the US and Europe are spending billions on trying to develop hydrogen fuel cell cars so that, we could have, like, a literal zero emission vehicle this way. Fuel cells use ongoing electrochemical reactions to produce electrical current, and similar to a battery, but instead of recharging, you add more fuel to the chemical reaction, basically putting more hydrogen in there, and you get both electricity and water for your car. If we were talking space shuttle, well, it could be used that way on the space shuttle as well. This is just a schematic of the hydrogen fuel cell. You're not going to have to memorize it, but for those of you that were, like, curious of how it's designed, there you go. Okay. Fuel cells can provide direct current, electricity, or DC current as long as they're supplied with hydrogen and oxygen. So you just keep refilling that thing, and, like, the battery is good to go. Okay. So the hydrogen can be supplied as pure gas, or a reformer can be used for safety, as hydrogen gas can be explosive, to strip hydrogen from other fuels, and then you just take oxygen in from the air, and that keeps your battery fresh, that keeps your car running, and yeah, so that's a pretty slick system. Okay. The efficiency of the fuel cell is about 40 to 45%. Current is proportional to the size of the electrodes in a fuel cell, but voltage is limited to 1.23 volts per cell. So the cells will have to be stacked in the car until you get the desired, like, charge level or power level, so that you can, like, maintain freeway speeds and stuff like that. There are tiny fuel cells that are running on methanol that could be used in something like a cell phone or toys instead of batteries, which would be awesome, because then, like, your cell phone could just, like, run indefinitely on this stuff. Okay. Again, the biggest issue with the fuel cell is a distribution system. We don't have, like, hydrogen stations all over, for people to stop and get a fill up. So that's probably going to be the biggest sticking problem for this. So in a nutshell, here's some pros and cons. Hydrogen fuel cells, pros, well, they basically like only waste is water, and it's renewable. Their environmental impact is low. There's very little, if any, greenhouse gases. I mean, water vapor is a greenhouse gas, but it's natural, and it can be like used in plants and animals, and comes down from the atmosphere in the form of rain. Super high efficiency. The cons, net energy cost, right? You need energy to split the hydrogen from the oxygen, so there's a big energy loss in that process, being that you're about 45% efficient. That's still better than like photosynthesis, but it's gonna require a constant input of energy to offset that. And you need fossil fuels for energy to split hydrogen to make hydrogen gas. They're going to be expensive, and there's no distribution system. It's going to take a long time to phase it in. Okay. All right. So again, how do we improve transportation? Well, you got choices. You could kind of look at like, fuel cell cars. You could look at plug-ins, hybrid, electric, whatever. At the end of the day, like, we just need to improve our transportation efficiency. That might mean that we pass laws to increase fuel economy, forcing automakers to up the average from 20 miles to the gallon to 30 miles to the gallon. We could have a gas guzzler tax. So if you drive a car that, I don't know, gets less than 15 miles to the gallon, then you have an added tax associated with that car. At the end of the day, cars do last a long time. So, it's a big investment. If you spent $40,000 on a car and, you got less than 5 years of use out of it, you'd be really unhappy. Okay. So there are cars that are on the road that are 20, 30, 40 years old, and they don't have all the modern technology in them to help them get, good gas mileage or even reduce emissions. So that's a problem. What do we do about that? How do we encourage people to buy new cars that are more efficient? We can't even really get people to use mass transit in communities like ours. If you live someplace like LA or San Francisco, having a car, it can be very, very expensive. So a lot of people use mass transit, and it's no big deal. In a community like ours, smaller communities, smaller cities, mass transit is kind of an afterthought. Very few people ride buses. Okay. We could give greater tax incentives for hybrids, plug-in hybrids, and electric vehicles to encourage people to buy them. One of the arguments against these vehicles is they can cost anywhere from $5,000 to $10,000 more than their regular internal combustion engine or ICE engines. And so, people look at that and go, well, I can't afford an extra $5,000 or $10,000 for my car. If we had a tax incentive that basically said, okay, we're going to pay you $5,000 to buy, a hybrid, then bring it down to a cost that's equal to a gas car, maybe that would help. Okay. So next thing we're going to get into is just some alternative energy sources that are not related to transportation. Okay. So as we get into things that are not related to transportation, one of the things that I'm going to throw your way is solar energy. Okay. So yeah, I know you could put like solar panels on a car, but that's not what this is all about. Okay. So solar energy is a vast resource that, for lack of a better way to put it, is largely underutilized. And it comes in two forms: passive and active solar energy. The average amount of solar energy arriving on top of the atmosphere is about 1,300 watts per square meter. The amount reaching the surface is 10,000 times more than all commercial energy used annually. So if we could somehow figure out a way to harness all this energy, like, we could be completely independent of fossil fuel. Until recently, the energy source had basically been too diffuse and low intensity to capitalize for energy. So it was just like, let go. Okay. So here's the two different types of solar energy you need to be familiar with. This is passive solar energy. Passive solar energy is really just used in like maybe heating a building or lighting a house. If you face your house the proper direction to gain, say, afternoon sun, you're going to add a lot of heat and light to your house as the setting sun in the afternoon shines in your windows. Okay. So that's the idea of passive solar heating. In the winter, there's a low sun angle, so that could mean you get more light in a house and make it warmer. In the summer, you get a high sun angle, you want less light, and you want your house to be cooler. Active solar is all about collecting the sun's energy in one of two ways. You're going to collect it in some sort of solar collector to maybe heat water, or you're going to use a photovoltaic cell to just generate electricity directly. Active solar or thermal solar heating has been around for a really long time. It's used for swimming pools. Some people, like, that's their hot water heater for their house. They put a tank up on the roof, and the sun's energy warms the water that way. Okay, and then it's circulated through the house or circulated through the pool. In a photovoltaic system, those are the things that we're starting to see a lot more, especially in states like California, but really throughout the United States. You have a photovoltaic cell that reacts to the photons of sun or sunlight, and basically that triggers a reaction that gets electrons moving, and those moving electrons basically are DC electricity that goes to an inverter that converts that DC electricity into alternating current, and you can use that to turn your lights on. Pretty dang cool. Okay, so this is how the photovoltaic cell works. So the sun's light excites those electrons in the cell. This thing's missing the inverter, but you still get the idea. Okay. So solar energy is huge. You can see that around the world that we are increasing our utilization of solar energy. Japan and Europe, along with parts of China, are outpacing the rest of the world. The U.S. is still kind of behind in getting solar energy going, but at least, it's starting to take off. Okay. So solar energy, at the end of the day, can provide a massive amount of renewable energy resources for us. Here's a little bit more text on each of these. Passive solar heat is using the absorptive structures with no moving parts to gather and hold heat energy like a greenhouse. And active solar heating is where we will pump heat absorbing medium through a collector rather than passively collecting it. Water heating consumes about 15% of a U.S. Energy budget. A flat panel of 5 meters squared can provide enough hot water for an average family on a daily basis. Unless you got a bunch of teenagers in your house that take like half-hour long showers, like, you should be okay. China produces 80% of the solar water heaters of the world, right? You can even use solar to cook your food. That's a solar oven. Hopefully we'll get a chance to make some of those in class because they're kind of fun. This is an example of a green building where not only are they taking advantage of solar heating, but also, solar energy to provide electricity, but also the solar heating through the windows in the front of the house. And then they've got extra insulation because they've got the sod on the roof and things like that to hold in that heat or to keep their house cool in the summer months. Another common thing that we're starting to see a lot with solar energy is this. These are solar fields. Now, I got to be honest with you, there's kind of a debate going on which is better. On one hand, solar energy is a renewable energy resource, and it's great to be able to collect this free energy source that's bombarding our planet, but it leaves a massive footprint behind. This area that maybe was once like field or something has to be plowed and completely denuded of plants. Animals have to be kept out of there, and somebody's got to then come back through and tend to these panels. There's also a fossil fuel quotient that has to be met to make these panels, as well as precious metals that are used in the panel production. So there's still the burning question of whether or not we're going to be able to keep up with like solar panel production at the scale that we would need in order to power all of the energy needs for a country like ours. Okay. We can even do what's called high temperature solar energy. If you've traveled to Vegas recently, you may have been able to look outside of your car as you're going down Highway 15 and seen a couple examples of high temperature solar energy production. There they use parabolic mirrors that are curved surfaces to kind of focus light at a receptacle, and that's going to heat a medium to generate steam and subsequently make electricity that way. Let me just show you a picture, okay? So this is what one looks like. You've got rings of parabolically shaped mirrors that are all focused at the center tower, and in that tower, there's a liquid medium that is heated. It's kind of like taking a magnifying glass and like fine tuning the beam until it gets super hot. You can boil water, you could generate steam, and then make electricity that way. Here's another example of how that works. So the solar thermal power tower, right, gets all of that, focused sunlight right at it. There are some people that don't like these things. Again, they can be a little bit of an eyesore when you're driving by. You definitely will see that tower glowing in the distance. And believe it or not, I'm sorry, I shouldn't laugh, but they do have issues with birds flying through there, and they literally get nuked by the beam that is shining at the tower. Okay, that's how that works. Now, there's another form of thermal heating that involves, instead of focusing at a tower, they'll focus at a tube around the parabolic mirror. So you've got the mirror that's laying down at ground level, and then it's got a curved shape, and then these tubes, again with a liquid medium in it, are literally laying across the tops of these mirrors, and the sunlight is focused right on that tube to boil the water, generate steam, and make electricity that way. Here's another view, right, of the concentrated solar power plant that is outside Vegas. So sunlight's reflected the top tower. It melts salt. The salt can be stored for up to 12 hours. And the higher specific heat of salt is used to store that heat, and then can be used to create steam and generate electricity. Okay, so that's the deal with solar power. Only solar power tower in U.S. They're in the Southern California area. They've just put that one in Vegas. The World Watch Institute estimates that U.S. deserts could actually produce 7,000 gigawatts of solar electricity from facilities just like this. But what's the trade-off, right? You're gonna lose land, and you're gonna lose plants, and you're gonna lose animals as you do that. Okay, so let's just jump to the pros and cons of solar power, and then we'll take a break and go on to our next video. So the pros of solar: it's free energy, has a moderate net energy yield, easy installation, minimal greenhouse gas production, minimal pollution, minimal maintenance, doesn't work on cloudy nights, the initial cost is high, and you definitely have to have lots and lots of space to do it. All right, gang, we're going to pause here, and I'm going to come back with part 2, where we look at hydroelectric, wind power, and biomass, and other renewable forms of energy. Okay, I'll see you in a minute.